Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Combined Science Specimen Paper from Chemistry Paper 1 Higher Tier. And question number 4 is on chemical changes. Copper can be produced from copper 2 sulfate solution by two different methods. Method 1, electrolysis. To produce copper by electrolysis, a student has inert electrodes. When they say inert electrodes, they're usually referring to either graphite electrodes or titanium. Titanium is more inert than graphite. A DC power supply, a switch, and electrical wires for the external circuit. Draw and label the apparatus set up to produce copper from copper 2 sulfate shown by electrolysis. So I have a pre-made diagram. Let me show you that. There you go. So we have a beaker. It's not labeled here. Carbon graphite electrodes, or you can label that as inert. Electrodes. So inert. That's a copper sulfate solution, DC, and what's missing is actually a switch. So if I was to add a switch, a closed switch in this case, so that the circuit is not broken, and that gives you the 2 marks. Suggest why the color of the copper 2 sulfate solution fades during electrolysis. Now, this copper 2 sulfate solution is usually blue in color, and that's mainly because of this copper ion. Now, during electrolysis, what you're doing is actually removing the copper from the solution and adding it to one of the electrodes, which usually the negative electrode, because the copper ion is actually going to be attracted to the negative electrode because it's positively charged. So as the copper is being removed, you've got less and less of the copper 2 ion. So the blue color slowly fades away. Answer. Copper ions cause the blue color. Copper ions are reduced and converted to copper atoms at the negative electrode. So the concentration of copper ions decreased, causing the color to fade. Question 4.3. Explain how copper is produced from copper 2 sulfate solution by electrolysis. So they are asking for the steps in what's actually happening here. As I said, the copper 2 sulfate, when you mix in water, it breaks down into the copper ion and the sulfate ion. And we are only worried about the copper ion. The copper ion, which is in solution, is attracted to the negative electrode. Here it will actually gain 2 electrons to reduce it because it's gaining electron and to become copper atoms, and the copper is actually going to be deposited here. So the answer copper ions are positive, is Cu2 plus. Let me write that properly. Cu2 plus. So are attracted to the inert cathode or inert negative electrode. The copper ions gain 2 electrons at the inert cathode. So they are reduced to form copper atoms, and that gives you the 4 marks. You can write a half equation for that. This is a little bit of fun to revise. Cu2 plus 2 electrons gives you Cu. That's the solid. That's aqueous. Method 2, displacement reaction. The chemical equation for the displacement of copper using iron is, so you've got copper sulfate plus iron gives you copper plus iron sulfate. Calculate the minimum mass of iron needed to displace all of the copper from 50 centimeter cube of copper 2 sulfate solution. The concentration of the copper 2 sulfate solution is 80 gram. There would be 80 gram per dm cube. Per dm, when 1 dm cube is equal to 1000 centimeter cube. So the first step is to find out how many grams of copper have you actually got, because you only got 50 centimeter cube. So if I divide 80 by 1000, I will find out how many grams are in 1 centimeter cube. Then I need to multiply that by 50 to give me the mass of copper in 50 centimeter cube. So let's do that. So 80 divided by 1000 is 0.085. Then multiply that by 50 gives me 4 grams. So that's 4 grams in 50 centimeter cube. Give your answer to two significant figures, that's okay. So calculate the minimum mass of iron needed. So how much iron are you actually going to need in terms of grams? What you have is 4 grams of copper sulfate according to our calculation. Now, a symbol equation, this is a balanced symbol equation, states that 1 mole of copper sulfate is reacting with 1 mole of iron to give 1 mole of copper plus 1 mole of iron sulfate. This is the reacting ratio. So I need to convert this 4 grams into moles. If I convert this 4 grams into moles, then it'll be the same number of moles of iron that is actually reacting, and then I can convert it back to grams. So the molecular mass of copper sulfate. Copper is 63.5 according to this, plus sulfur is 32, plus there's 4 oxygen here, so 4 times 16. So let's do that in the calculator. Let's try with 4 times 16 is 64, add 32, add 63.5, that gives me 159.5 grams. So 159.5 grams equals 1 mole. So how much is 4 grams then? 4 grams equals, we would 4 divided by 159.5. So 4 divided by 159.5. That gives me 0.025 moles. So what we found was that we are reacting 0.025 moles of copper sulfate, and that should give us the same moles of iron. 0.25 moles of iron. And how do I convert 0.025 moles of iron? You multiply it by the relative atomic mass. So 0.025 multiplied by 56. So multiply that by 56. That gives me 1.4. Right. So that's equals 1.404. We only need it for 2 decimal. So 1.4 grams. That brings us to the end of question number 4, and I will see you in question number 5.